given f dash of 2 is equal to 6 and f dash of 1 is equal to 4, and limit h tends to 0, f of 2h plus 2 plus h square minus f of 2 divided by f of h minus h square plus 1 minus f of 1, which is equal to, so for some time let's consider 2h plus h square is equal to some p and h minus h square is equal to some q. As h tends to 0, so 2h plus h square tends to 0, so which implies p also tends to 0. Also we can say q also tends to 0. So let me write the limit h tends to 0 here. F of, this is a p plus 2 minus f of 2 divided by p plus 2 minus 2, that is p, and multiplying with p, and again into 1 upon f of q plus 1 minus f of 1, here multiply and divide with the q here, p by q, so that we can feel this problem as limit h tends to 0, f of p plus 2 minus f of 2 by p plus 2 minus 2 is nothing but f dash of 2 for p tends to 0. Let me write here, limit p tends to 0, f of p plus 2 minus f of 2 divided by p plus 2 minus 2 into p upon q into here the limit 1 upon, let me write, so 1 upon limit q tends to 0, f of q plus 1 minus f of 1 divided by q, and p upon q, let me write it as, okay, in the next step I will write, so this is nothing but f of p plus 2 minus f of 2 divided by p plus 2 minus 2 is nothing but f dash of 2, this is f dash of 2 into p is nothing but 2h square, we can write here limit h tends to 0, let me apply the limit h, p is 2h plus h square, or h if I take common 2 plus h square divided by q, q is if I take h common 1 minus h into 1 divided by f dash of 1. Since f dash of 2 is equal to 6, so this is 6 into limit h tends to 0, it comes here 2 upon 1 into 1 upon f dash of 1 is equal to 4. 6 2s are 12 upon 4 will give the answer 3. So we can give the answer 3, which is option 1. This is the answer.